Hello, I'm Vijay Singh, and welcome to Season 2, Episode 2 of our GOfermentor Winery Chat. As is our tradition, I spend the first few minutes talking about something of general interest that you will find interesting as winemakers, wine lovers. So today's topic is this book, The Widow Clicquot. This is a history of the lady who invented basically Vive Clicquot, 18th century businesswoman. The book is really interesting. She was widowed at 27. People thought she would give up the business. No, she took the reins and she basically figured out how to make the champagne without any residual yeast. And then her genius was marketing and business. She went on to become one of the most famous businessmen in France and the richest woman in France. So go out, get this book, The Widow Clicquot, pour yourself a glass of Vive Clicquot, and celebrate the invention of champagne. Again, I don't get any promotional benefits of doing this. I only promote GOfermentor products. So buy some champagne, buy the book, Amazon, The Widow Clicquot, enjoy yourself. You'll learn something not only about wine, but about a most remarkable woman. Okay, let's go on to our topic for today. We're going to talk about using CO2 evolution from the fermentation to estimate fermentation metabolism and even the ethanol concentration in the fermenter. First of all, why monitor fermentation activity? There are many reasons. You want to check to see the fermentation stuck. You know what I mean by stuck? Nothing happens, nothing grows, no alcohol is formed, it's just sitting there. So you want to know, if it's stuck, you got to do something. You want to know if the fermentation's finished. In other words, all the sugar has been used up and the amount of alcohol that's going to be formed is now complete. Now, the alcohol is the most interesting parameter. And there are many, many ways to estimate ethanol, but they're all kind of tedious and difficult. I'll just review some. You could use the refractive index, basically a Brix measurement. It's cheap. It's not very accurate, and it requires you compensate for the starting Brix very carefully. And there are tables for this and spreadsheets. It's not exactly a very elegant technique. You can also measure specific gravity. Take a sample, measure specific gravity, and again, you have to compensate for sugar loss, alcohol increase, and also remember, you need a fairly big sample for this. So it's again not very elegant. You can use an eboliometer and distill the sample. This is very complicated and expensive, and it's really only done for finished wine. You want to find out the alcohol concentration for the label. There are enzymatic machines that do a wet chemistry analysis, give you sugar and alcohol. You have to take a sample, involve some wet chemistry. And then there are optical devices which use infrared spectra to estimate the alcohol. These are wonderful, but they cost at least $20,000 and are out of the range of most small wineries and small winemakers. Now, one thing I always like, I'm very lazy about certain things, but I also believe that you should get stuff for free. There's stuff going on, and all we have to do is measure it, and then we get information for free. So let's see what we can do here. We can monitor the amount of CO2 that's evolved. Now, what is the point of this? Well, in the beginning, say the first 20 hours or so, we're not that interested because there isn't much CO2. The yeast is going in an aerobic phase. It's metabolizing the sugar, it's making proteins, it's making yeast. There's a very small amount of CO2 being produced, and there's no ethanol. Once we get into the anaerobic phase, now all the air is being used up. The yeast is now metabolizing the glucose, making alcohol. Now, this is the pathway. There's a simplified version of it, but you need to understand this to understand the whole concept here. Okay, so you start on the left side with glucose. The yeast takes in the glucose, it makes an intermediate called pyruvate, which then degrades to release molecules of CO2, which are marked by that numeral 2 on this diagram. That pyruvate goes to acetaldehyde and finally is excreted as ethanol. Ethanol is basically nothing but yeast shit. It's the waste product of the whole system. But, one man's shit is another man's gain. That's how this works. So, we can look at a profile of evolution of CO2 during the fermentation. So on the x-axis, you see hours. So this fermentation ran about, I don't know, 10, 11 days, something like that. And on the y-axis, we have the liters of CO2 that were evolved. You see in the beginning, we have the lag phase. Okay, here the yeasts are still growing. There's not much activity going on in terms of CO2. Then we get into an exponential phase. Now the yeast are happy as pigs in shit, pigs in sugar really. And they're consuming the sugar as fast as they can, and they're making a lot of CO2. Finally, near the end, the sugar is exhausted. So now the yeast are basically starving, and they will eventually die off. So you see the CO2 levels off as the metabolic activity comes to a stop. So 2 points here. First of all, just by monitoring CO2, you get a good idea of what your fermentation is doing. What I said to you earlier, metabolic parameters. Are you growing? Are you making alcohol actively? Or are you done making alcohol and your sugar is done, consumed, finished? Now, let's look at it a little more carefully. If you go back and go back to the slide I showed you with the mechanism, it's really all about stoichiometry. Okay? For every mole of CO2 evolved, a mole of ethanol is formed. Okay? And in other words, if I transfer it to grams, for every 44 grams of CO2 evolved, I get 46 grams of alcohol. Now, I can work out how much ethanol in the liters I would get from that amount of CO2. Remember, 1 mole of CO2, 1 mole of ethanol. We can work out the stoichiometry and you get this equation where you take the amount of CO2 evolved, multiply by 0.0026, and it'll give you the liters of pure ethanol in the fermentation. This basically means that 1 liter of CO2 gives you 2.6 milliliters of ethanol. Now, to get the concentration in the fermentation, it's very simple. You just divide it by the fermentation volume. So you have the ethanol in liters, divide by the fermentation volume in liters, multiply by 100, and you get your ethanol percentage volume by volume, liter by liter in the fermentation. So let's look at that data I showed you earlier, where I showed you the CO2 evolution. Let's feed that data into our program, and it will generate the estimate of ethanol from the cumulative concentration of CO2 released during the whole fermentation. Now, before we go to that, our system is unique. We do our fermentation, as you know, in bags. Now, these bags only allow the vent gases to go out through a single orifice, the vent valve. All the CO2 must pass through this vent valve. So all we have to do is replace this vent valve with a special vent valve that has a gas sensor in it. So now all the gases leaving the fermenter has to go through this flow sensor, and it will basically measure how much CO2 is being generated every minute. So we take that data and we have it now calculate the estimated ethanol. So I want you to spend a few minutes on this graph because it's very interesting. The blue points are the actual measurements. So we took samples from the fermentation, ran them on an ENOFOS FTIR analyzer, and that gave us the actual volume by volume ethanol concentration. The red line is the online real-time estimate of the alcohol levels using only the CO2 evolution. And you can see it's remarkably accurate predicting the ethanol. You should be able to predict within, say, 0.25%. So this gives you a tremendous tool to actually watch the ethanol production in real time without even taking samples. So this is now available from our GOfermentor operation. The original GOfermentor vent valve, you're familiar with it, it has a little spring activated thing. It has a valve that opens during the punch operation. This valve can be replaced with one that has a gas flow sensor internal to it. So it looks just slightly bigger. It's got the electronics strapped to the side of it, and it's got a gas inlet that funnels the flow into the sensor. It replaces the standard vent valve. And we're actually going to have a program for our customers where you can return the original vent valve, and we'll upgrade it to a vent valve with the CO2 sensor in it. The same device is also available for JR. The original GOfermentor JR valve is shown on the right side. It's a simple check valve that only allows flow out. It doesn't allow flow to go back into the fermenter. So it's now replaced by a slightly different valve. It's in the vertical orientation now because the condensate in the valve must drip back into the fermenter to not damage the gas flow sensor. So it has a silicone one-way valve, again allowing gas to leave the system but not allowing any air to enter the system. And this little device that you see in the vertical is the gas flow sensor. And it's connected via a small cable to the front panel of the GOfermentor Junior controller. And this again, we'll be providing instructions how to retrofit these. It's very simple. The software can be downloaded online and you can convert your existing equipment to this advanced upgraded CO2 monitoring ethanol estimating device. Now, we really only focus on GOfermentor products. You know, I only believe in everything should be in a bag, right? But people came to me and said, this device would be very interesting for home winemakers and other people who don't really work with either junior or net. What about carboys, small drums, tanks, what have you? And even though it hurts me when people do it outside the bag, but I felt that this would be a device interesting enough to make it into a standalone vent monitor. So we now have a device, you can see here, it looks similar to the one for junior. It has a silicone one-way valve, so there's no need to add any water or any water trap that eventually always causes trouble. It has a color LCD display on it. You can see the CO2 evolved, you can see the ethanol estimate, you can enter in the volume, so it'll calculate the concentration for you. It has some graphing features there. You can see that it can be mounted on a standard bung, and that bung can be inserted into a carboy, as you see on the bottom part of this drawing, or a tank or bag or whatever you want. The limit is kind of around 200 liters fermentation volume. That's its maximum limit. Again, we also offer an app, so you can actually monitor the standalone vent remotely over the internet from anywhere. And this is going to be marketed to really the home winemaker market, and it's going to be about $250, something like that. We haven't quite set the price yet. Oh, and before I forget, the vents for junior are going to be about $200, and the vents for net will be around $450, and we'll obviously give you a trade-in allowance to units that you send back to us. So, just to summarize the topic today, great benefits in monitoring CO2 evolution. And in our system, it's free because everything comes out of a single vent, and we can measure that gas precisely. So we can monitor fermentation progress, we can estimate the ethanol concentration, there's no sampling needed, it's real time, you can see it on your app from anywhere, about 0.25% volume by volume is the accuracy, and it's low cost, you know, a couple of $100 to $300, very, very affordable product from GOfermentor. We are taking pre-orders online, so you can order the part and we will ship it, I believe, in another 4 to 6 weeks. So that's our episode 2 show. I hope you enjoyed it. Email any comments to me, any suggestions for future shows. And here we are enjoying our Vive Clicquot, and this is the scene in the back, our farm, with a glorious rainbow that appeared yesterday. Cheers. See you next time.